This is a gesture-controlled robot that demonstrates how tilt-based input can control motor movement. So let's get started. Here's what we will need for this project. One Arduino UNO MPU-6050 Module, one L298 motor driver, two DC geared motors with compatible wheels, one double battery holder, two lithium-ion batteries, solid core wire for breadboard and other connections, wire strippers, and two Wheel Acrylic Car Chassis with its accessories. Let's start the assembling the car chassis. Mount the caster wheel using the screws and bolts which come with the chassis kit. Mount the motor properly on the chassis and pass the wire from the holes provided. Connect the wheel by matching the slot on the wheel and motor shaft. Now chassis assembly is complete. Let's set up the circuit for the robot. Refer to the wiring diagram in the description or pause the video to view the on-screen circuit diagram. Paste the Arduino, battery holder and motor driver here on the chassis. Take 4 solid core wires and insert them in the MPU module. Connect the VCC of the module to the 5V pin of Arduino. Connect the GND of the module to the GND of Arduino. Connect the SCL and SDA pins of the module to A5 and A4 of the Arduino respectively. For the L298 motor driver, connect in 1 to Arduino digital pin 5, IN2 to Arduino digital pin 6, connect IN3 to Arduino digital pin 10 and IN4 to digital pin 9. Connect the motor terminals to the output pins of the motor driver. Let's connect the power source to the motor driver. Insert the red wire of the battery holder in the 12V slot of the driver and black wire in the GND slot of the driver. Let's power the Arduino from this. Insert a jumper wire from the GND of the motor driver to the GND of Arduino. And also insert a jumper wire from the 5V slot of the motor driver to the 5V pin of Arduino. Now download the code and library files given in the description below. Open the code file in the Arduino IDE. The first line includes the wire library which allows Arduino to communicate with the MPU-6050 using the I2C protocol. We then define the I2C address of the MPU-6050 as 0x68. Next, we declare variable ACX, ACY and ACZ to store the accelerometer readings. Finally, we specify the control pins for the L298 motor driver which will control the movement of the robot. In the setup function, we configure the motor pins as output using pin mode. Next, we initialize communication with the MPU-6050 using wire.begin and wake it up by writing 0x6b to its power management register. Finally, we start the serial monitor with serial.begin 9600 to debug and display accelerometer readings. Here how we read the data from the MPU-6050. Start communication with where.begin transmission function and specify the register 0x3b which contains accelerometer data. Request 6 bytes of data using where.requestFrom function. Combine high and low bytes of data to get 16-bit accelerometer values for the X, Y and Z axes. Print these values to the serial monitor for debugging and understanding tilt gestures. Now we control the motors based on the accelerometer's X-axis value. If ACX is greater than 6000, we call the move forward function. If ACX is less than -6000, we call the move backward function. Otherwise, we call stop motors function to stop the robot. Here are the motor control functions. In move forward function, we set IN1 and IN3 to high and IN2 and IN4 to low to make both motors spin forward. In move backward function, we reverse the high and low pins to make the motor spin backward. In stop motor function, all pins are set to low, stopping the motors. And that's how the code works. Now connect the Arduino UNO to your computer using the USB cable for uploading the code. Select port and board in the same menu and select Arduino UNO. Now click on the upload button. And that's it. Switch it on, your gesture control robot is ready. Tilt the MPU-6050 forward to move the robot forward, backward to move it backward and keep it level to stop. I hope you found this tutorial helpful. Thanks for watching our tutorial.